Hi guys, in this specific video we're going to look at the concept of internal energy and work. Now we have defined the concept of work from our first discussion on the concept of energy, whereby we said that energy can be roughly regarded as the ability to do work. And we had said that we can be able to describe work in terms of force, whereby we said work is a product of force times distance. So therefore, whenever perhaps a pressure or something is applied, as a force is applied over a specific kind of a distance, we can be able to describe that a form of energy which is applied in form of work given as such. So in changing from one form of energy to another, we're going to see that what we refer to as a matter under consideration or rather system is going to do some kind of work or some work being done on this specific type of a system respectively. So we can be able to perceive a system as having two situations whereby the system is either going to do work or the work is going to be done onto the system respectively. Now, if the system does work, then we're going to see that work is going to be a negative value if work is done on the system, and when the system is, of course, going to be involving the aspect of doing work, then therefore we're going to see that the notations for the positive value, let's just give a notation for work given as such. So in this case, I've said that if the system does work, then work is going to be a negative value. So we're going to give this one as a negative, just give this is going to be a negative value. And if work is done on the system, then it's going to assume a positive value as such. So therefore, if we try to consider this specific case, you can perceive this one in form of heat energy. If we try to look at the system in terms of perhaps some kind of a compressed gas, I'm going to give that. So this is going to be also in terms of heat energy, which is going to perform that specific work. So I'm going to give my illustration at this specific point, whereby if we have a gas that is confined in a particular cylinder, then therefore we can be able to look at that gas in terms of this specific illustration, whereby this is going to be a gas that is confined in a cylinder, and then this system is closed as such. So therefore, if you try to provide some heat energy to this system, it's going to move this particular nozzle, the piston, as I can refer it, towards the upper direction, and it's going to perform some kind of work. So if we try to consider it from that specific perspective, then we're going to see that the system is going to absorb heat energy from this specific surrounding, in which the heat therefore is going to be regarded as a positive. So therefore, if the system takes in the heat energy, then the heat is going to be a positive one. So therefore, the energy is going to be regarded as positive. But if the system, of course, dissipates or takes away heat, and then therefore we're going to have the work energy described as a negative value. So when a system changes from one state to another, perhaps from this specific perspective or this one, we're going to see that its internal energy is going to change by a value that we're going to refer to as delta E. So both cases are going to involve a change in energy, but the magnitude of this energy is going to be given in terms of delta E, which at some time the system, of course, is going to do work which we have said, or perhaps involve the release or absorption of heat, as I've mentioned. So therefore, we can be able to give a relationship that is going to exist between this specific change of energy and the work which has been done in this case. So we can be able to describe the change in energy of this specific system as the difference between the heat energy and the work done given as such. So therefore, this gives us a relationship whereby we can as well describe the heat energy in this system as the change in energy and the work done given as such. So for a large amount of energy, we're going to have this one have an implication of energy being the total heat absorbed from the surrounding, whereby there's a portion that is used to perform work and therefore also we're going to have the one that is going to be used as work of expansion in that specific case that I've given for this particular illustration that I've given, which is being applied with some heat given as such. So we can be able to describe this specific energy, total heat absorbed from the surrounding in terms of the energy, internal energy of the system that is being changed by delta E, and the work that is done, of course, in trying to cause that specific expansion. So in a sense, we're going to see that this is going to give the relationship between the internal energy and work. And from this particular relationship, then therefore we're going to consider different aspects which we have measured, which are going to affect this particular system, especially the concept of temperature and the pressure, which are the variables which are going to affect how this system and the energy are going to be described in particular. So our next video is going to consist of a range of description for various forms of or states of energy insofar as temperature and pressure are concerned. And this, of course, is going to give us a clue on how various laws can be described, especially on the concept of a conservation of energy and various forms of matter, ether, gases, solids, and liquids. So catch us in our next video as we're going to explore this concept of internal energy and work, and give various forms or descriptions of various forms of energy in terms of temperature and pressure, and some of the terms that are going to be used to describe these various states of energy. So that is it for now. Catch us in our next video. God bless you.